Hello, welcome to another episode of Azure Community MTS. My name is Nicholas, and I'm joined with Wesley Hadwick, my co-host for this episode. And Wesley is a Microsoft Azure MVP, principal Azure architect at Intercept.
Yeah, thank you for having me, Nick. Happy to be here.
No worries.
It's a public holiday somewhere in Ireland, so I guess today I'm blessed to be here with you.
Thanks.
Looking forward to today. We got some good sessions.
Yeah, have some session today. So before we get started, we just want to give you some housekeeping. So let me just share my screen. Can you see the screen? So yeah.
Not yet.
Can you see now?
Now we can.
Okay, cool. Yeah, so welcome. And so this is some like a code of conduct. So all members of this group should abide by this code of conduct, be friendly, welcoming to everyone, be patient, be thoughtful, and be respectful, inclusive. So include everyone, and be open and curious. So always ask questions to understand something you're unsure about and not to criticize.
All right, and we've got a very good agenda today. And if you're not watching today, but you're watching next episode, there's going to be a session from Konstantinos Pasadis. I hope I'm not butchering your name, but PI data masking and cognitive services. That sounds really interesting. And there's a session coming up from Nils Fransens next time, co-pilot for Azure. But today, we'll talk about the first session in a second. The second session is going to be by Velida on Radius, which I've played with before myself, and I find it really interesting, and I love the concept of internal developer platforms. But for now, the first session, we're going to look at Dapr. A wonderful solution. It's been out for a couple of years, and I mean, if you're a developer or your ops, talk about Dapr to your developers because it provides so many awesome features. This man does not need an introduction. I've seen several sessions from him. I am wondering where the hat is, though. But
yeah, he always wears his Dapr hat. Yeah, he's green.
I'm missing the Dapr hat, but I'm really looking forward to this session on Dapr by Marc. Okay. So, there's some stuff happening backstage, but we'll see. Okay. Yeah, let's go to the next slide before we start.
So before we get started, we just want to get everyone to ask questions to make the session more interactive. So we all want everyone to learn, and let's learn from each other. So let's bring the guests in. So the first guest would be Marc.
Hey everyone.
Hey Marc.
Thanks for inviting me.
I did see something backstage. I know it's
troublesome. Yeah, so I do have a hat here. Well, actually, this is the backup hat because I'm traveling to Stockholm tomorrow to Sweat Talk. So the let's say the primary hat is already packaged, but this is the backup hat because I lost the original hat once. Long story. This is the backup hat, but when I'm wearing these headphones, I can't really wear the hat as well. So yeah, I need a solution when doing these live online things. But yeah, so the hat is here, but I won't be wearing it.
All right, but at least we've seen it. It still
exists. You've seen the hat.
We've seen
it. Iconic.
Yeah.
The famous hat.
Yeah, and I'll definitely be wearing it indeed at Sweat Talk in Stockholm on Wednesday when I give my Dapr session there. So because then I won't be wearing this huge headset.
Nice. All right, nice. Dapr.
Would you like, before we get started, do you want to tell what the session's about, Marc?
Yeah, so this session is really like a Dapr introduction session. So if you've never have seen Dapr, never seen the APIs or what it can offer you, then this is like a good intro for you. If you already have seen it and already have played with it, then probably I don't have a lot of news to share, maybe unless until the end of it, because we are doing some nice things at the Dike which I can also share. But yeah, it's just like a good introduction session for Dapr, brilliant. And mostly for developers.
Brilliant.
All right. Let's go. Right.
Let me share my screen.
All right. Got it.
All
There we
right,
go.
perfect. All right. So the session is titled "Start Building Applications with Ease Using Building Block APIs." Like I mentioned, it's really like a Dapr one-on-one session, mostly focused for application developers. It's like 50% slides, 50% demos. We get all the slides done first, and then we move into the code samples. I will hide this. All right. So already got a very nice introduction. Thank you. I'm Marc Dulker. I'm Senior Developer Advocate for Digrid, and that's a company founded by the co-creators of Dapr. That's Mark Vassel and Jeroen Snyder. And Digrid builds like commercial solutions in the Dapr ecosystem. But I'll share a bit more at the end of this session. I'm also an Azure MVP. I'm also one of the Dapr community managers. So Dapr has these bi-weekly community calls, and then everyone can join that. And we share some information, the latest features about Dapr. And we also have some Dapr end users joining and sharing their knowledge as well. So usually very nice sessions. They also get shared on YouTube, so you can also watch those back. And I'm a really big fan of pixel art. I've been drawing that for quite a couple of years now, and these days also my slides are in pixel art, so I hope you enjoy those.
Okay. So, Mark, before you get started, do you want to talk about the Dapr community manager? Like, what your role is?
Yeah, sure. Yeah. So let's get back a bit. Yeah. So I'm hired by Digrid as a senior developer advocate. So I'm creating lots of content for Digrid, and I can focus mostly on Dapr open source, which is great. But I also have this, let's say this side role as well as a Dapr community manager, and that means like, hey, I'm trying to manage the Dapr community, trying to make it a welcome place for everyone. If people have questions, that they can join the Dapr Discord, and I try to find the right channels and the right people for them to help them further. I'm also trying to make it easier for people to contribute to Dapr. Recently I've created like a video on how to contribute to the Dapr documentation, for instance, and also added a dev container to the Dapr docs repos. You can also use like GitHub code spaces now to easily contribute to Dapr. So yeah, I'm trying to make it easier for contributors, for new contributors to help work on Dapr, but also I want to need help Dapr end users to also be successful with Dapr.
Brilliant.
All right. Okay, so what I'm going to talk about now is some developer challenges that that developers face when they are building distributed applications. I'm going to talk about Dapr APIs. We'll talk about components, how they work, and then there will be lots of demos, and for sure there will be some time for Q&A as well. So a lot of organizations are like building distributed applications, and maybe it's not exactly this type of distributed applications, but it's a lot about different services, and they need to communicate with each other. A lot of different resources are involved, like different state stores and message brokers and so on. And it doesn't matter what kind of technology you use, but there's always certain developer challenges that you're facing. For instance, how you do like end-to-end tracing, right? Also known as distributed tracing in this kind of systems. So you want to be able to trace your call across different services and across different message brokers, for instance. So how do you do that in a consistent way? Another challenge is how can you actually do like service orchestration, right? So maybe you have some complex logic that you want to execute. You have like a certain order of different services or service calls that you want to invoke. But maybe in case something goes wrong, you want to do some compensation action on these services. So how can you do that in a good and resilient way? Another challenge is how do you deal with resiliency? So what happens if a call to a service fails, for instance, or whatever, if you want to communicate with a message broker, but it fails, and it can fail on the publishing side. It can also fail on the subscribing side. How does your application deal with that?
So this is a silly question, but these are the services in green, and the yellow is just the front end and the gateway. But what's the message broker? Something that handles the message?
Yes, so the message broker, this is like a messaging solution. So for instance, this could be like a service bus. So Azure Service Bus is a message broker. So you can, so this service, checkout service, can publish a message on this message broker, and this shipping service is then subscribed to messages that are published on here. So it's typically used for asynchronous communication. You just do a fire and forget publish of a message, and something else will actually consume that message.
Brilliant.
But good question. The final one is deals with security. So how do you actually regulate access between services and resources, right? So for instance, we have this inventory service here, and we only want to allow access to this inventory service from this card service, and we only allow access to the storage only from this inventory service. So those are quite common features that you want to want to make sure that works well across all these different services and also across many different languages. So if you're dealing with these kind of developer challenges, then Dapr, the distributed application runtime, is a good solution. Because Dapr has like built-in security and resiliency and observability capabilities. So how is this possible? Well, this is the same diagram, but now we see some Dapr logos next to these services. So Dapr runs next to your application. So you have the service, your application, but the Dapr service runs next to it. And if you're familiar in the cloud native space and working with Kubernetes, then you call this a sidecar. So there's a Dapr sidecar next to your application. And that takes care of all of the heavy lifting. So all of the communication that's happening between services and also across message brokers and also to different state stores, that's all handled via the Dapr sidecar. So the applications are not directly communicating with each other, or they're not directly communicating with state stores or with message brokers. They are communicating via a Dapr API, and then the Dapr sidecar takes care of all of the heavy lifting. So Dapr also speeds up Microsoft's development by providing like a really broad suite of APIs for communication, state, and workflow. And at the moment, there are 10 different APIs that Dapr is offering. I won't demo all of them. I won't also like describe all of them because it's really quite a lot. But I'll definitely demonstrate the service verification one, the PubSub one, and also the state management one. And this is not like a fixed set of APIs, right? Because Dapr is released like every 3 to 4 months, and for every release, well, not every new release, but almost every new release, there is like a new API introduced as well. And of course, APIs are first in alpha stage, then in beta stage, and then they're final generally available. So also the maturity level changes there. But I think out of these 10 APIs, I think 7 of them are like completely matured, and there's like one alpha. I think this cryptography one is an alpha, and then the workflow and the distributed log are in beta. So it offers like a very big feature set of what you can do with it, which are very common features that developers use when they build distributed systems. And the APIs are just one part of the story. So the APIs are like very basic, easily understandable APIs that developers can use. But the implementation of the APIs, that is decoupled from them. So Dapr itself, Dapr is not a state store, and Dapr is not a message broker. It offers APIs, and it can actually integrate with all these different resources. And all these different resources, those are called components in the Dapr landscape. So you can use the Dapr State Management API on AWS to interact with DynamoDB, for instance, or on Azure Cosmos DB, or on Google Firebase, or on one of these open source solutions. But the State Management API is the same across all of these different state store implementations. So that's what really makes Dapr really powerful and also really flexible, and also quite versatile, because you can quite easily switch from one cloud provider to another one if you want to. I don't think that's the biggest selling point, because it's not very often that you need to switch from one cloud provider to another one. But for instance, when you're doing development, you can choose for instance, I'm doing like PubSub on my local development, and then I'm using like a local Redis container. But then when I move to production, then I can very easily switch to my Azure Service Bus without changing any code, because the publish subscribe API is still the same. So I'll give a demo of this later. So Dapr is a runtime because it runs in its own process for building distributed applications across cloud and edge. So what does it mean, cloud and edge? Well, basically it runs anywhere where you can run some form of Kubernetes. So you can run it on just plain Kubernetes, on any form of managed Kubernetes, which is of course available in any major cloud provider. And you can also just run it on your virtual or physical machine. I'll be running it on my laptop here. But there are like two services I want to call out specifically because they are quite new and a bit different than before. One is Azure Container Apps. That's really, I think, the most lightweight and easy way to get started with Dapr on Azure. It's still based on containers, but you don't have the overhead of managing your own cluster. So that's pretty nice, and it integrates really well if you're just using Azure resources, things like Cosmos DB or Service Bus, those kind of things. And the other one is Catalyst, and that is the new product by Digrid, and that's really like a true serverless way to consume Dapr APIs. This won't be like a demo of Catalyst, but I'll share a link later where you can sign up for this. So we're actually still building this product, so it's in a sort of private beta at the moment.
Sorry, quick question, Mark, just for me. So if you, for example, you spin up Dapr in Container App in Azure, can you just switch it to Catalyst for Dapr easily? Because you say you can use with multi-cloud, like different cloud provider as well.
You can actually switch quite easily to Catalyst and to something else, because Catalyst you only get some endpoint with Catalyst. So Catalyst is really quite unique in that point. So you can actually combine Catalyst with any other cloud. And for all of the other solutions, you're usually tied to one solution, right? So you either run your complete workload on Azure or on GCP or on AWS. So usually you're tied to one cloud. But with Catalyst, it's really, really flexible.
But you can do multi-cloud, like if you have an organization with like AWS and Azure, you can
definitely. Oh, that's definitely true.
AWS container.
That's definitely true. You can still easily connect one services running on one cloud to another cloud. That's definitely true. Yeah.
Okay. And on-prem as well, right? You said virtual.
Yes,
machine.
exactly. There's lots of companies who are very concerned about either privacy or regulations in India, and they need to run it like air-gapped, so they don't have any internet connection. So then it's still possible to run Dapr either on their own virtual machines or just on a completely disconnected Kubernetes cluster.
Yeah.
And so it can basically run anywhere, and also you can run Kubernetes on a Raspberry Pi, right? You can use like something like Minikube or something. So you can even run Dapr on a very small device if you want. Okay, so a bit of zooming out now about the Dapr project. So Dapr originally came from Microsoft quite some years ago. In 2021, it was submitted to the CNCF. At the moment, it's in incubation maturity level. And Mark Vossel, one of the co-creators, has done like a proposal to move it to the graduated level. Hopefully that will happen sometime this year, but there's still quite some administration work involved there. But it's very likely to happen. And at the moment, it's around the 11th largest CNCF project out there, which is quite impressive, given that there's like a immense landscape with all of the different CNCF tools and products out there. So there's a lot of work happening on Dapr, right? So I'm from Digrid, and I have a lot of colleagues working like full-time on Dapr. So that's great, but there are a lot of like large organizations working on Dapr and contributing to Dapr as well. So that's always good to see. That's always also important from a perspective that it's a really like solid solution, right? It's not just dependent of that single developer somewhere in the middle of nowhere. There's actually quite a lot of people working on it. Also, there's a lot of usage of Dapr. So these are all Dapr end users, and also quite a lot of big names in there. Okay, so let's have a look at how this works with the sidecar and the Dapr API. So you have your application on the left, and that application can be written in any language. Doesn't matter as long as it speaks HTTP or gRPC, because the Dapr sidecar has the Dapr API that's exposed on HTTP and gRPC. Things you can do in your application is that you can invoke like different kind of endpoints in order to use the Dapr features. So in case you want to invoke this order endpoint to invoke a method on another service, you can do a post to this endpoint. In case you want to retrieve some state, you can use this state endpoint. If you want to publish a message on a topic of a message broker, you can use this publish endpoint. If you want to retrieve a secret, you can use the secrets API. And workflows is one of the newer APIs, and this is how you can actually start a workflow. And these are all of the basic HTTP commands, but there are also still a lot of client SDKs for all of the major languages. These are just the 5 most popular ones, but there are even more. I mean, basically, you mentioned the Rust SDK just before we started, so that's also one of them. But we also still have like a PHP client as well. So SDKs are all over the place. But these are definitely the top 5.
Mark, I got a question from Richard. Sidecar, do you have to use sidecar containers?
Do you have to use a sidecar container? I'm not sure if I get that question. Otherwise, I can clarify later on, though.
Yeah. Okay.
I think that depends on how you're using Dapr, right? If you're integrating it into your code or whether you're exposing Dapr APIs as a container sidecar container within your pod.
Oh, right, exactly. Yeah, indeed. Yeah, and actually there are more ways that Dapr can be used right now, though. So let's say the default on Kubernetes is indeed the sidecar, but there's also a thing called Dapr Shared, which is really new, and then you can use like a Kubernetes daemon set that hosts the Dapr process. So then you don't have a Dapr sidecar per service anymore, but then different services can use actually the same Dapr process to access the Dapr API. That is like super new. It's actually like in a sandbox project now in the Dapr org on GitHub. So if you
we don't have that yet.
It's on GitHub. You can try it. You can try it, but it's like it's very early stage on it. So, but you just Google Dapr Shared on GitHub, and then you get it. Or I can drop that later as well.
Mark, I got another question. You said we can use Dapr to run on different languages. Is there like quickest way to like switch between different? When you said different API, because you put in different like 5 API before. And do you just have to connect to it and then run the command again, connect again like 5 times? Or is there a way to switch between these like post, gets and stuff? Or is it just the command you just type these?
Well, you would write code, and your code would actually construct these endpoints and execute these endpoints, right? So you make an HTTP request to these endpoints. So that's one way of doing it. So you can make these raw HTTP requests. The other way of doing it, and especially if you come from more like a typed language such as C# or Java, then it's probably easier to make use of these client SDKs, right? So you have actual objects that you can talk to and can develop with. So for
so
the
these
.NET
would be
there,
different type of SDK, like Python, Go, or Java.
Exactly. Yeah, exactly. Yeah, indeed. Yeah. But this is just like it makes it easier to consume the Dapr API, but you can still use the Dapr API even if there's not a client SDK for it. Yeah. All right. Okay, so let's do an example now of how this works with the different components and how your application works with the Dapr sidecar and the component that's being used underneath. So let's say you have an application that talks to Cosmos DB, and if you weren't using Dapr, then you would use a client SDK of Azure in your application here. But in this case, we're using Dapr. So there's a Dapr sidecar. So your application actually talks to the Dapr sidecar in order to interact with the state management. So there are some methods like save state async, and it uses some kind of a name, and get state async. And so this is in case of the C# SDK. So all your application needs to know is the name of a certain component that you're using. And this is then it's completely unaware of any Cosmos DB specific code. But the Dapr sidecar does need to know that it needs to store its data or needs to retrieve data from Cosmos DB. So how does this Dapr sidecar know? Well, there's a component file. So there's a YAML file that's located with your source code. And this YAML file that contains the name that you're referring to in your code, in this case, the my storage. And it also contains a type, in this case of CosmosDB, it contains a type state.azure CosmosDB, and then it contains some metadata values, which I did not include here, which usually include some kind of a connection string and stuff. So with this combination of this YAML file that contains the link of this name and the actual state type, and the developer uses this name in the source code, and this is the way that Dapr actually figures out, okay, my storage is actually linked to CosmosDB. Now, if you want to change this CosmosDB for something else, so maybe you're using CosmosDB in production, but maybe locally you want to use Redis, all you need to do is switch this YAML file into like a different specification type. So if you switch this to state.redis and provide some different connection data here, then your application is talking to Redis, and your application code is not changing. So that's what I specifically like when I'm developing just locally and running locally, and then moving to production. It's quite easy just to switch out this YAML file to change the underlying type. And I'll actually show the reverse from going from Redis to CosmosDB in a demo later. So one thing I often hear that, okay, Dapr is like runs in the sidecar. So is Dapr like a service mesh then? That's actually not the case. So that's the short answer. But the bit of a longer answer is, okay, there are definitely like similarities between like Dapr and the service mesh. So have both enable like a secure communication, both collect metrics, and both do distributed tracing. But yeah, then that's the end of it, because Dapr is really like a developer-centric solution. It's really about all of the APIs that it offers and all of the components that it offers. And the service mesh is really centered around infrastructure. So it's really about network traffic and routing, and Dapr does not do anything of that. And there are a lot of organizations that use both together. Right? So they use the Dapr APIs, but they also use something like Istio if they want to do like traffic management and routing. So they work very well together. Okay, so when would you use Dapr? I think there are like two major use cases. So either you're part of a very large organization that has like many different teams that are building on this distributed application, because when you're building distributed systems, it's usually an indication of team size or organization size. Or you're using lots of different technology stacks, because one team might build something in .NET, another team might build something in Python, another one in Java, other one in Node.js. But you can still then use Dapr, because all of the security policies and all of the resiliency policies, you write all in the same format. That's all in YAML files. So you can actually reuse that across all teams. The other situation is quite the opposite. Then you can really think about like greenfield projects. So maybe it's like a startup that wants to create something new. And if they decide to immediately use Dapr, you can actually postpone all kinds of other architectural decisions. So you can actually already start building something locally or on a test environment. And maybe first this just runs locally, but later on you can switch out components and then very easily deploy your resources on Azure, or switch your YAML files and deploy on AWS or on GCP. So you stay very flexible if you start using Dapr from Go. All right, it's time for some demos now. So the demos I'll run them from a forked repo from Dapr Quickstarts. So if you want to try this yourself, definitely have a look at github.com/Dapr/Quickstarts. And I'll start with, first things first, I'll be using the Dapr CLI to run Dapr locally. And when you run applications with the Dapr CLI, you get a Dapr process that's running locally. And so that's your Dapr sidecar. But if you install the CLI, you also get some additional containers running locally. The first one is the Dapr actor placement. This is only required when you use the Dapr actor API. I won't cover that in this one. That's actually a whole separate talk. I will be using Redis because Redis is used as the default state management resource, and also the PubSub resource. So I'll definitely use this. And Zipkin is used as the tracing solution. So I'll also show you that. So the first one is the service invocation API. So the sample that I'll show is a C# sample. It has like two projects, a checkout project, and this checkout will make a request and it will post it to this order processor. So let's switch to VS Code. Okay, so this is the quick starts repo here. And as you can see, it has a lot of subfolders, and for each of the APIs that Dapr offers, there's like a subfolder. I'm a really big fan of an extension called Code Tour in VS Code. That's this one. Tour. And with Code Tour, you can create some kind of a guided tour through your source code. And actually, you can also execute commands using Code Tour. So I really like it when I'm giving demos because it makes it easier for me to actually do a proper guide through this quick starts. Yeah.
You can execute command in sequence, in order.
Yeah, you can actually execute commands in this code where I'll show you in it. It's super
nice.
useful. So I've like configured 3 code tours here, and these code tours are not part of the Dapr quick starts yet. So I'll make a contribution to that because they now exist only for C#. So I'll also need to create them for the other languages. But let's start with the service invocation code tour. So let's first have a look at the checkout project. So here we are now in the service invocation folder and in the C# folder, and there's this checkout folder that contains our first application. It's a .NET application based on .NET 8, and that's it. So we're not using the .NET SDK here. We'll be just using the HTTP API to make a request to the order processor. So if you look at the program CS file, make this a bit smaller. So to see here, we have a base URL. That's basically like falls back to localhost, but otherwise we get a Dapr HTTP base URL. We create a new HTTP client, and then we set 2 headers. Well, one header is the media type, which is application JSON, but the other one is very important and specific to Dapr. So the other header that we set is the Dapr app ID, and this contains the application ID of the service that we are going to call. So this is how Dapr actually figures out how to find this other service. And then we do a for loop, and we create a new order. We serialize it. We create the content for the request. And here we use the HTTP client and do a post to this base URL with an orders endpoint. So that's the endpoint on the order processor service. And we provide the content there. And we do a write line order passed. So on the other side, so this is the service that is receiving it. That's a web application, also based on .NET 8. Again, no specific Dapr SDKs here. And if you look at the program CS file here, we see that there's an orders endpoint that was also specified in the checkout service. And here we also do like a console write line order received, and we just return the same order again. So no fancy business logic, just like pinging some orders back and forth. All right, so all of the samples in this Dapr Quick Starts folder use the Dapr CLI to start the applications. And Dapr CLI now has a feature called Dapr Multi-App Run. So before there was multi-app run, you had to start like 2 separate processes, one for the checkout service and one for the order processor service. So you had to use like 2 terminals and start each process separately. But now with multi-app run, you can actually specify in a YAML file. So that's this dapr.yaml file. You can specify what applications you want to run. You give them all an ID, you specify a port, you specify a command that needs to be ran. In this case, they're both like .NET, so .NET Run is used. And you specify what the application path is. So we can just run 2 applications or even more applications with just one command, which makes it a lot easier to just run and test multiple services at once. So that's what we're going to do now. I'm now still in the root folder of this repo. So now I'm going to navigate to this HTTP folder. And this is what I mean is you can execute certain commands using GoTour. So instead of typing this out or copying this, I can actually just click this and the terminal will switch to the right folder for me. And here I'm using Dapr multi-app run. So I do Dapr run -f and then the dot. And that's like the default notation because it will actually use this Dapr.yaml file to actually build and run the applications. So I'll do that now. Make this a bit bigger. And here we see the console logs, right? So we see order received, and since it's request response, after it's received, we see the console log of that the order is passed. So here we see that the service invocation is working. So I'm gonna look it. Right. So we've seen the stuff in the console, but I also want to show you the output of the tracing in Zipkin. Of course, that gets loaded in another window. Here we go. So this is Zipkin that also gets installed in a container locally with you. And if I do like a refresh here, I ran a query. Here we can see that the checkout service made a post to an orders endpoint here. And if we actually expand this, we can see the checkout service and the order processor service. And we can see the timings and stuff like that. So this is the built-in distributed tracing at work. Okay, navigating back to the root, and let's move on to the PubSub example. Let's actually first do this. The next is PubSub. So essentially we have the same thing again. So we have a checkout service with a Dapr process, and we have an order processor service again with a Dapr process. But now we are using a message broker. And in this case, we're using the built-in, or let's say built-in message broker. We're using Redis as a message broker, and Redis is also like pre-installed if you use the Dapr CLI. All right. Okay, so let's run this PubSub code to now. So again, that has like the 2 services very similar to our previous example, the checkout and a order processor. Again, the checkout service is a .NET service in .NET 8. Now we are using the SDK. So there's a reference to Dapr ASP.NET Core. So now we are using the Dapr SDK to actually access the Dapr API. So this is the program CS file of the checkout service. So a similar thing is happening. We do like a for loop, but now we use the Dapr client builder to build us a Dapr client that we're going to use. And here you see that we are using the publish event async method. And here we refer to a component. So this is new because now we are using a component. We're using a message broker now, and we're using the order PubSub. There is a file here somewhere that also contains this PubSub name. I'll show that a bit later.
Is that why it's got a squiggly line on order PubSub?
No, this is just like a the spelling. So the dictionary thinks it's. I don't understand this word.
Okay.
So we're using a component named order PubSub, and we are publishing to a topic called orders, and this is the payload because we created an order here. And then we do a console write line, and then we wait a second, and then we do the next one. And so this is the publisher side, and now let's go to the subscriber side. So again, this is a .NET web application. Again, it's .NET 8, and we are also using the Dapr client here as well. So if you look at the program file here, what's important to know, Dapr PubSub wraps the messages that you send in cloud events. And it does that because it enables the distributed tracing part. So if and any event that is sent will be wrapped in a cloud event, and a cloud event is like an open standard. A lot of tools already support cloud events, but not all message brokers might implement it or might follow the same standard. But since Dapr is wrapping it in its own cloud event, you're always certain that you can do like distributed tracing and have the proper metadata. So that's why you have to mention it here, so to actually also unwrap the event that's coming in again. What we're also seeing is we are mapping a subscribe handler, and this enables you to actually map one of these endpoints. So this is the orders endpoint, but this method will actually receive a message that is subscribed to this topic. So here we see a topic definition. We see the same component name again, order pops up, that we saw on the publishing side as well. And this is the topic name. So these things also appeared on the other side. And again, we do like a console write line, and we do a return OK with the actual order. So we've seen the applications, but there's still one thing we haven't seen yet, and that's the definition of the order pops up component. And that's also what is specified here. So in this dapr.yaml file, so in this multi-app run file, we have, let's say, the same definitions of our two applications, but now there's also a reference to a resources path. So let's have a look what's in that resources path here. Actually, two things, one observability and one pops up YAML, and that's what's open now. So here you can see the name that's also referred to in both applications. We were referring to an order pops up component. So that's this one. And in this case, we are using popsup.redis as the popsup type. And there's some connection data here to connect to Redis. Okay, so let's run this. Let's move to the right folder. Let's use Dapr multi-app run to start the two applications. And then we should immediately see the publish and subscribe. So we can see indeed we are publishing and subscribing. So this is working. Great. That. And again, we can also see those traces in Zipkin as well. It opens again in another window. Okay. Right, so what we can see here is we see the checkout application, and we can actually see it, or maybe I need to zoom in a bit. We can see that it's doing a publish event to Dapr endpoint. And here we can see the same information as before, but this is now across a message broker. So we can see that one application is publishing it, and we see that the order processor is actually receiving it. All right. Let's move on to the final one, the state management one. This is a bit of a larger example. So now we have just one application though, using Dapr sidecar to interact with a state store. We'll start out with Redis, but we actually will change the YAML file to make it point to Cosmos DB. And I'm also going to show you how resiliency works in Dapr as well. Okay, so we're now in the state management folder, and this is the program.cs file. Again, it's the same thing, .NET 8. We are using the SDK again, so that's why we have included this package. So here's the program.cs file. Some more using, as you can see. So here we have a reference of a component type again. So we have now a variable called the Dapr store name. So this refers to a name that's mentioned in a component file again. We'll see that later. Again, we're using the Dapr client here, and we are iterating now even 100 items. And we create an order, and we use the Dapr client to actually save the state. When we save state, we mention which component name we're using, in this case, state store. And the Dapr state API is like a key value API. So we need to specify the key. So in this case, we use the order ID as a key. And in this case, we do like a toString on the order, because I think that's like there's an override on the order, I think. Yeah. And what we do then is, after we save it, we immediately get the same thing. It might not be very useful, but there's just like a basic example to show you how the state API works. So when you want to retrieve a state, you mention the output type, you mention the component name again, and you mention the key that you're using to retrieve it. I've commented out the delete state, otherwise it gets a bit tricky to actually show you some stuff in the state store itself. So right now, when I run this, things will be saved, it will be retrieved, and then I can actually show you the state store. Yeah.
One question: how did you get the output type? Because this is just a string. Did you get it from the state? Do you just have to query the state to get the output?
Well, you have to know what you put in.
Okay.
So this can also be like a complex object in this case, but in this case, the order is like a very simplistic thing. And so it's like an order record, but it only has an ID of type int. But you can put in a complex object here if you want. So that doesn't matter. But the key has to be a string. So that's important. But the value itself can be any serializable object.
Okay.
All right. So let's have a look at the Dapr multi-app run file. In this case, there's only one app that we're running, but we're still referencing to a resources path. So let's have a look at the resources path there. Well, that's this. I still need to do it actually. We're starting out with Redis. And then we can switch to Cosmos. This is the Redis configuration for the state store. So the state store name was also referred to in our application, and this one, all right, and this is of state.redis. So this is the one that's going to be used first. And there are also some other configurations. I'll explain them a bit later. Let's run the sample first, and let's see what happens. Okay, so now it's starting. It says saving order, getting order, etc. So this is working. That's great. But now I want to introduce you to the resiliency part of Dapr. So Dapr is now using Redis as the state store, and Redis is running in a container. So what can we do to simulate a problem with Redis? We can actually stop the Redis container. So I can actually list all of the things that are running now. And so these are the Dapr specific ones, and we are going to stop this Dapr Redis container, and we're going to see what happens then. So in this container, it's now at 15. And it's topping, but it's also not throwing an exception, right? So the program is halting, but there's nothing very serious happening. So Dapr is actually trying to retry this and actually trying if it can succeed, but at the moment it can't because the whole container is stopped. But as soon as we start the container again, so we can do start Redis, then it will simply continue where it left off. So now it continues with 16, 17, and so on. So how is this possible? I'll actually stop this now. So this is possible because of this resiliency.yaml file. So this is how you specify the resiliency of, in this case, a connection of a service with a state store. So what you can do here is you can define some retry policies. In this case, we give it a name, retry forever. It's a constant policy. It has like a duration of 5 seconds, and we want to last it until eternity, right? So this is the max retries. If it's negative, then it keeps retrying. We can also introduce like circuit breakers. So we want to periodically check, okay, is the connection still gone, right? Because we don't want to overload our backend with continuous retries. So we can also like configure circuit breakers here. You then specify which targets you want to apply these policies to. These can be like services or components. In this case, it's a component, and you have to specify the name of the component. And in this case, it's an outbound connection. So we go from our servers to the state store. And then you specify the names of the retry policy and the circuit breaker. So these things can be very fine-grained, and you can also scope them on certain services. So this is only scoped for the order processor. So you can actually provide different resiliency policies to different types of services. Just to show you that actually there is data. Should have something here. Yeah, so this is like a Redis visualizer on this container, so we can actually see that the orders are there. So that's good. So now let's swap out this Redis with Cosmos DB, and let me first show you that the Cosmos DB container is empty, because I might be cheating, of course. Okay, so we have this Dapr Cosmos DB database with a KV container in there, and at the moment that is completely empty. All right. So what we're now going to do is I am going to rename this temporary YAML file, because that was not loaded in the Dapr process. So I'm going to rename that to just .yaml, and I'm going to apply the temp naming to the Redis one. So whenever I start the Dapr CLI now, this Redis one won't be read in anymore, but this Cosmos DB one, that will be read in. So this configuration will be used instead. And since I'm using the same name, the same state store name, my application code is just referring to the state store name. So this is the Cosmos DB configuration. I'm actually using the Dapr API, the Dapr Secrets API in this, because I'm not actually using primary keys or Cosmos DB URLs in this configuration, because I want to keep those secret. I am referring to a certain Cosmos DB database and a Cosmos DB container, but I'm using like secret key references in Dapr. So in here, I am saying, okay, I have configured a secret store. In this case, the name is local secret store, and that actually defines where my secrets are stored. So that actually refers to this secrets.yaml, which has the name local secret store. In this case, since I'm just developing locally, it's just a very basic local file that has my secrets. So in my application, there is a secrets.json, and that contains, in this case, the primary key to connect to my Cosmos DB. But the Dapr secret store can also be used with, for instance, Azure Key Vault or Kubernetes secrets. Okay, so now let's run this. I've showed this. This can go. Let's do Dapr run now. And now it will use Cosmos DB. So I will quickly switch here. Then I need to refresh to see some documents coming in. And here we go. Now you have like documents coming in to Cosmos DB. Also, because we don't have to wait and see 100 records coming in. Right, so that was like a quick demo of 3 of the, let's say, popular Dapr APIs. Had the thing I mentioned about Diagrid earlier. At Diagrid, we are building like commercial solutions in the Dapr ecosystem. So if you're running Dapr in production on a large scale, so you have like hundreds of services or thousands of services running on Dapr, and then we have like a tool to help you manage your Dapr clusters. It's called Conductor. And it's really quite a time saver if you're running really large Dapr installations. The other tool, which I'm also very excited about, is called Catalyst. And that actually allows you to use the Dapr APIs from anywhere. So you can even use it from an Azure function or from an AWS Lambda. So this is not tied anymore to the sidecar model because we are actually hosting the Dapr process for you. All right. So thanks. You have survived this presentation. Feel free to scan this QR code. It links to a HoloPin badge that you see here on the left. If you want to claim that, you need like a GitHub account to actually claim it. But feel free to do that.
I'm doing that.
There's one more question from Richard. It said, does .NET Aspire and does Dapr work well together?
Yes, they do. And in the next Dapr community call, which actually is this Wednesday, that'll be demoed by Microsoft.
Very nice.
So I think indeed, David will actually demo it himself. Yeah.
All right.
Yeah.
I've got questions as well.
Sure.
So, I know that Conductor does a lot of tracing and provides you with insights, but I'm a huge fan of OpenTelemetry.
Mm-hmm.
I heard and I saw that there's very good integrations with OpenTelemetry as well. Do you see that a lot?
Well, to be honest, I haven't seen that much myself yet, because I'm also not having a lot of close contact with many end customers, right? So I don't have that much visibility on that. So what we have is you still need to hook up your own, let's say, telemetry endpoints or whatever you want to push your telemetry into Dapr, right? So whenever you use like something called Azure Monitor or Grafana or Datadog or whatever, so you still have to configure that. I think that part is relatively easy, but I think the tricky part is probably from how detailed do you want your telemetry to be, right? And then it's you still need to tweak it on a certain level, and that's more like application dependence probably, or maybe some middleware dependent, and there's probably where Dapr can probably grow and probably do more than we can do now. So I think the initial setup is probably easy to get started with, but then you probably want more, and then there's some work involved probably.
Yeah, but then we can still always resort to Conductor because it'll
definitely, yeah, exactly, yeah, indeed, right. Yeah.
I also looked up Dapr Shared. I need that. I want that. So I'm going to be playing with that.
Yeah, cool.
And well, you said it was developer focused, and Dapr is obviously a very good solution for developers. My takeaway is I'm an ops person, even though I do little development, but I mean, all developers need to listen to the ops people. Don't forget that. No, I think what was very cool is that you showed where you show going from Redis to Cosmos DB, but also going from a local secrets file. And from my understanding, from what I saw here today, as an ops person, I could also go, hey, developer, you want to run that locally, use the local secrets file. Yeah. You will still interact with the Dapr APIs as you do, and just develop your way and make it beautiful. But as an ops person, I will attach an Azure Key Vault in the backend or something else, and it will just work the same way. I think that's as an ops person, I think it's very, very good to understand this and understand Dapr, because it will provide you with options that you can provide to your developers.
Yeah. There's a very clear cut line of what you can do as a developer and what you can do on the operation side. And definitely when it comes to these configurable YAML files, and you can have one part just for developers and just have the other part for production. So that's really one of the strengths. Yeah,
I like it. I love it. It's
cool.
Good. Thank you.
Anyone have any more questions, or is just all good? Okay, so let's just introduce the next speakers.
And thank you, Marc. Thank you for taking the time.
Yeah, thanks for joining, Marc.
My pleasure.
Even though it's just like, let's introduce. So the next speaker is Will Velida.
Hey, everyone.
So he's doing an introduction to Radius to give us, because Radius is recently out last year, I think, from Microsoft Ignite. So it's quite good cloud native tools to get used to and for everyone to know. Would you like to introduce yourself, Will?
Sure. Hey, everyone. I'm Will Velida. I'm a lead software engineer for Mantle Group. Now, we are a technical tech consultancy based in Australia. So I'm living in Melbourne at the moment, but we've got folks in Sydney, Perth, Brisbane, even some folks in New Zealand as well. So we go across the ANZ region.
Yep, and he's even got the hoodie as well, Mantle Group.
Yeah, it was starting to get a little bit cold. I'm wearing a bird person t-shirt underneath this, which we were having a bit of a joke about in the lobby before we started streaming. But then I started getting a bit cold. So yeah, they give us swag every year, which is pretty nice. This year it's a polo shirt, which I haven't managed to pick one up yet. Last year it was one of these jumpers, so I got one of these jumpers, which is handy because when I joined in August, that's when winter is in Australia. And it was something like 4 degrees on average during the day. Yeah, Melbourne has very variable weather. So in the morning it could be really sunny, but then 5 seconds later you'll need your raincoat and then you'll need to put a jumper on. Yeah, it's crazy. We're on the front lines of climate change here. It's great.
Crazy. It's different weather compared to Sydney, though. That's the thing.
Yeah, Sydney is, well, recently it's just been very hot. So over the weekend it was 38 degrees in Melbourne. In Sydney it was something like 42, something ridiculous. I would just melt in those conditions. 38 is, not great, but 42 is just another level.
Okay. So we have someone's looking forward to learn more about Radius. Someone excited.
Awesome. Hopefully I don't let them down.
So if you share your screen, I'll share it to present it. So you should be able to see the present button, Will.
Do. Just make sure I share the entire screen. So you should see slides. I'll also hide that.
Yep. I just leave everyone in. The floor is yours, Mike, Will.
Awesome. Fantastic. Cool. So hello, everyone. If you're just joining, my name is Will Velida. I'm a lead software engineer for Mantle Group. And today we're going to be talking about Radius. So in a previous life, I used to work for Microsoft. So I managed to get a little bit of an insight into what was known as Project Radius before it was released. And then when they released it, they just called it Radius Project. So they just flipped the words around, which was cool naming strategy. So today we're going to be learning about building and operating cloud native applications with Radius, because Radius is a project that attempts to kind of bridge the gap between developers and operators when it comes to building cloud native applications. A little bit about who I am. I'm a software engineer or lead software engineer for Mantle Group. We have little brands within the Mantle Group. So I work for a brand called Azenix within Mantle Group. That is we mainly focus on the Microsoft space. So Azure, .NET, all those wonderful things. That's who the kind of technologies I work in. I'm a former Microsofter. Before that, I was an MVP based in Auckland. Towards the end of last year, I moved over to Melbourne, Australia, and I'm loving it. My background is really in .NET development and also Azure development with experience in the banking, agriculture, and health industry. So a bit of a variety there. And I used to play rugby a little bit. I actually moved to New Zealand to play a little bit of rugby, but I was very average compared to all the Kiwis. So I gave that up and decided to do a little bit of coding instead. Cool. So today we're going to take a real gentle introduction into what Radius is and cover some of the key concepts. So what applications are, what recipes are, environments are, and what all that means in the context of Radius. Then we'll do a little bit of deep dive into the Radius architecture. So kind of take off the covers a little bit and see what's inside for the Radius API and how the architecture works. And then we'll jump into a very basic demo where we'll actually build a Radius application from scratch. So to take a step back a little bit, if anyone's seen this diagram before and worked in the CNCF space, you'll know that applications are a lot more than just Kubernetes. There's so much that we need to think about, and there's also a lot of choice out there. So when we think about technologies that we might want to use for messaging, for proxies, for container registries, API gateways, there's a lot to choose from, and it can get very confusing. And there are lots of common problems that we face as developers and operators when it comes to building cloud-native applications. Now, standardizing on Kubernetes has been successful for most enterprises. It does come with a lot of complexity, though. We don't just run our applications on Kubernetes. We don't just package them up into containers and then deploy them to Kubernetes, and then that's it. Maintaining and operating all of our resources that our application needs is a full-time job, and this is where platform engineers, site reliability engineers come into play. There are full-time jobs to actually maintain our resources. We also don't develop in isolation anymore, and we really shouldn't. There are some organizations that can be quite siloed. So software developers sit here, they build an API or they build an executable, they pass it off to an ops team, and they kind of deploy it. They don't really have an understanding of it, but they're just there to maintain it, and they're responsible to make sure the thing keeps running. But to develop the type of complex applications that enterprises usually build, we need developers, platform engineers, and IT operations people to collaborate. And the tools that we need to use to do those things need to help us aid our collaboration, not impede it. And as I was mentioning before, platform engineers, it's kind of two sides of a coin. So you've got your platform engineers that will support applications, usually lack context about the architecture of the application itself. So they just kind of get this executable. They're like, what's this thing? They might hook it up to various monitoring stuff just to see, okay, what's going on. And when something goes wrong, they'll call an app developer, say, hey, something's wrong in your application. You need to fix it. And then on the flip side, app developers will lack context about the underlying cloud infrastructure. So they'll build their API, but they'll have no idea of the compute platform it runs on, or the data store that needs to interact with, how petitioning might work for a particular data store. And this causes a lot of problems. So together, we need to actually have a common understanding and visualization of what our application is doing, what it's built on, and what it does. So this is where Radius comes in. This is a nice quote that I've stolen from the Radius docs. So Radius is an open source cloud native application platform that enables developers and operators to develop and collaborate on cloud native apps across public and private clouds. A very nice long sentence, but that's essentially what it is. It's this platform that kind of enables developers and operators to actually come together and get a mutual understanding of what the application is, how we're going to develop it, and also how we're going to operate this application as well. So just a little bit about what developer and operator collaboration means in the context of Radius. Developers will define their applications and dependencies. Operators will define the environments that those applications will run on. And so using Radius, we kind of bring those two together, deploying applications and infrastructure that kind of meets both of our requirements. So starting from applications. So Radius applications are the primary resources, or primary resource that brings all your services, dependencies, and relationships together. It gives you a single description of your application, allowing you to deploy and manage your application easily. And the way that it does this, Radius applications can be captured via an application graph. And you can query this application graph, which can help you gain a little bit of an understanding of how your application kind of all fits together and how you can actually deploy your application as well. Now, Radius applications are designed to be cloud and platform agnostic. So once you define your application, you can deploy it to any cloud platform that Radius supports. Now, currently, that's only Azure and AWS, but essentially, as a developer and operator, you define the components of your application, and you can point that to Azure, you can point that to AWS, or you can point it to both. This actually opens up a lot of great use cases if we need to move apps between clouds, if you're moving from AWS to Azure or vice versa, or if you've got an on-prem application and you want to move that to the cloud, you can kind of use Radius to kind of capture what it looks like on-prem and then deploy that to the cloud. Developers can then, define the requirements and dependencies, and operators can define their environments and recipes, that bind those requirements to those appropriate cloud resources. Now, I've used the word recipes there, and this is a pretty fundamental concept in Radius. So what Radius recipes are, they are essentially a separation of concern between IT operators and developers by automating infrastructure deployment. So developers will, when they're developing their application, they'll select the resources that they want in their application. So they may need a state store, they may need a cache, they may need a message broker. And what platform engineers will do is they'll codify within their environment how these resources should be deployed and configured. So for example, if as a developer, I know this application needs a cache, I may be working alongside a platform engineer going, okay, a cache for us is we'll deploy an Azure cache for Redis. We'll be deploying that within a virtual network. So we're going to need a private endpoint. Private endpoints are only supported for a particular SKU for Azure Cache for Redis. So we're going to need to define a SKU and a plan for this particular Redis cache. We might want to do some diagnostic logging on that cache as well. So as part of the recipe, we're going to make sure that we're going to add some monitoring and logging onto the Redis cache so we can keep an eye on the health and performance of the cache. So when a developer like myself deploys the application and its resources, recipes automatically deploy the backing infrastructure, and it will bind to my developer to the resources I've defined as a developer. So I don't need, as a software developer, to worry about how to configure my cache, my private endpoint. I don't need to worry about that. A platform engineer has already done that for me and has made it available to me via recipe. Now, currently, recipes support both Bicep and Terraform. You can use, so Radius actually comes, and I'll show a little bit of how this works in the demo later. Radius does provide recipes out of the box. But obviously the big power here is that you can actually provide your own custom recipes. So say if you're using configuration for a cache like this on the screen, you can actually code that up yourself and create your own recipe for it. If you're working with Azure policy for deploying resources to Azure, and you have certain policies you want to apply on it, you can actually codify that within your recipe as well. Moving on to...
Will,
Oh,
sorry, one question. So recipe is pretty much for us, like platform engineer, the resource that we deploy, and for developers would be the Radius, right? No, the...
So recipes,
if
we think about... So as a developer, I would say, okay, all I want is a cache. So I would define, there's like a special, in the demo, I'll show like a special resource type. There's like a namespace that says like applications dot like databases / Redis caches. There'll be like a namespace there that defines the recipe. So as a platform engineer, you would actually do that kind of the heavy lifting as well, saying, okay, we know this Redis cache needs to be integrated with the VNet, so we'll create a private endpoint for it. So you would do the heavy lifting with Bicep as a platform engineer, and then you make that available to developers. It would just be like, okay, sweet, I need a cache, here it is, rather than me as the developer having to do both.
Okay. Yeah, that makes sense, because we develop it and then we gave it to developer and they just say what they need.
Yeah, and that really helps with standardizing resources across the organization, and also between different environments as well. So you might have a specific recipe for a dev environment, you might have a specific recipe for production, so you can have a little bit of flexibility between the different recipes as well. Cool. So coming back to environments. So environments in Radius are essentially just a landing zone for applications that are really configured with your organization's policies, settings, and particular recipes that you have developed. They're essentially an encapsulation and store configuration for the compute platform, networking configuration, diagnostics, any other operational concerns that you might want to keep in mind or enforce when you're developing applications. And the great thing about environments is you can actually vary or configure environments to vary across different types of deployments. So you can have an environment for staging, you can have an environment for production. If you're deploying a multi-region application, you can define different environments for different deployment regions, or even different clouds. So if you're running active workloads between clouds, you can configure an environment that's specific to Azure. You can configure another environment that's specific to AWS. And essentially, platform engineers will collaborate with app developers by managing the set environments that developers can use. So when an application is deployed, Radius will actually bind the application that developers develop to the configuration of the target environment and then apply the relevant setting. And this really helps increase developer velocity, because as a developer, I don't need to change my application at all when it's deployed across different environments. So there's some basic concepts in Radius. So now we're going to just do a little bit of a deep dive into kind of the architecture of Radius. And there are really three parts to this. So there's kind of a general resource management API. Then you go down into your specific resource providers for cloud native applications and the different cloud providers, and then the tools for actually deploying and managing Radius applications via their API. So starting with the general resource management API, the Radius API itself kind of uses a centralized hub and spoke architecture, where it's the single entry point for authentication, authorization, routing, etc. So when I'm making requests to the Radius API, all that traffic will come through that central point, and validation is done there before we distribute that request or send that request, to the appropriate cloud resource provider. And this is what's known as a universal control plane. This is also a central point for extensibility. So each resource provider is actually registered centrally with the UCP, so it knows where to send requests for that particular resource type. So when I talk a little bit about resource providers, I'm not specifically targeting it. The namespaces aren't specific to a particular cloud provider, but within the resource itself, I could say, okay, this is going to be a cache on Azure, this is going to be a cache on AWS, or it's just going to be a default one that I'm going to use out of the box. The UCP, or Universal Control Plane, will actually route those requests to the specific clouds for that resource type. And this also contains functionality for federating with separate resource managers as well as the resource providers. So like I said, the UCP routes requests to Azure or AWS to also manage the resources that your application needs. So just a little bit of a high level on Radius provided resource providers. So the role of the resource provider is to really perform those CRUD operations associated with one or more resource types. Again, traffic is only accepted from the universal control plane, so it can assume that when any requests are made there, these requests are authorized. So when it sends those requests to specific resource providers, it's already been registered with the universal control plane, so it's authenticated. And so it goes, okay, this request is going to go to Azure, it's going to create an Azure Redis cache, or it's going to spin up a Mongo database in AWS. It knows where to send those requests. The applications resource provides the bulk of Radius user-facing functionality. So this is really for creating and managing the resources required to run our applications. This also helps respond to the CLI, storing dependency information for our application, like connection strings, and then just executing recipes to create cloud infrastructure. There's also support for bicep deployments as well. So if you have a specific bicep deployment, you can actually use that within Radius as well. And then finally, we've got tools that actually work with Radius to do so via the API. Throughout the demo, I'm going to be working with the RAD CLI to actually create my Radius application and also deploy it as well. The RAD CLI kind of not only manages creating of resources, but also manages the operational request to the API as well. Now, when it comes to creating our Radius resources, we can do so declaratively within a bicep file and then deploy it via the rad CLI. So once we send this request, the CLI actually monitors the bicep deployment resource, and we can actually see the progress of that deployment via the terminal, which we'll show in a demo. Terraform support is coming, still a work in progress. I think just checking out the docs, like the difference between Bicep and Terraform is that Terraform deployments are processed on the client that initiated the operation, and then the provider makes requests to the API to actually create resources as needed. Cool, so let's jump into demo. So I'm just going to exit out of that. How is my screen looking? It's looking pretty good.
Looks good.
Awesome. Okay, so in this demo, I'm just going to be, we're going to create a very basic Radius application. Now, to get started with Radius, you're going to need a supported Kubernetes cluster. So what I've got, if I just get this here, I've got a good old basic AKS cluster that I provisioned this morning. So that's where I'm going to deploy all my Radius applications. So I'll go back into here. I also need the rad CLI, and also at the moment, in VS Code, for those of you with a keen eye, this is the Visual Studio Code Insiders version, not the main stable one, because this extension here is basically a fork of the official Azure Bicep repository to support Radius, while they're kind of just doing some work to kind of make Radius compatible alongside Bicep. So at the time of recording, this is additional. It is from Microsoft. It's additional extension, Radius Bicep. I've used it in a Visual Studio Code Insiders build because when I try to run it side by side, it does play funny games and it kind of gets confused. So I've downloaded Visual Studio Code Insiders to actually work with this extension specifically. And you also need the rad CLI installed. So what I'm going to do, I'm just going to get more real estate here, and I'm going to start by creating a new directory, and I'm going to go into that directory. And then what I'm going to do is I'm going to initialize a new Radius environment with rad init. And what this does, it gets you up and running with a local development focused environment where most of the environment configuration is going to be handled for you, including recipes. You can customize that if you want. So you do have the ability to kind of fully customize your environment. Since we're setting up an application for the first time, I'm just going to press enter for next, for yes. And cool. So we're going to use, I've previously installed Radius on this cluster before, doing a little bit of rehearsal before we started going live. So I'm using my existing Radius. So when it initializes Radius, it's going to initialize Radius on your Kubernetes cluster. I'm using my existing environment, and I'm using my first application. And what's that has done, so in this My First App folder, it has created a little bit of a basic Bicep application for me. So here I've just got a simple container. So this is just going to be a core container that's run. It's going to just basically use this this image that the Radius project folks have provided. And we can actually also see kind of like a full application definition by running rad app show. There's my first app. I'm going to put the output for JSON. So here I can see information about my application that I've just deployed. So this ID is like the fully qualified resource ID that the universal control plane will use to recognize this application within the Radius system. You'll see this location global. For now, all applications kind of deployed to the global location, but it's kind of corresponding to your Kubernetes cluster. So if I just go back, I'm here in Melbourne, deploying to Australia East. I know Melbourne does have a data center right around the corner, but it doesn't have availability zones. I know my reliability folks are on the call. So, you know, you always use availability zones where you can. It is coming. But, you know, building 2 separate availability zones does take time. Anyway, then I've got environment. So this specifies the specific radius environment where my application is going to be binding to. This really determines where containers should run. So here I'm running it in Kubernetes. So that gives me more information about the environment. And this whole compute block specifies where running services in the application will run. So here I'm deploying it onto Kubernetes. Before the Radius project was kind of generally released, it was all just container apps. You didn't have the option when all the Microsoft insiders had to run it on Azure Container Apps, but now it's just limited to Kubernetes. So maybe in the future we'll see Radius being deployed to Azure Container Apps. Cool. So now let's take a look inside our application and see what's actually deployed. So if I run rad app connections, we should see nothing. So nothing's been deployed. So let's start building this out. So what I've got in this so far is I've just got a basic UI container. This is going to essentially just be a website that's going to be available to hit. So what I can do is I can actually run rad deploy and deploy that bicep file. If I could spell deploy properly. There we go. It's all right. When we're doing live demos, we just make happy little accidents. Okay, and what that's going to do is it's going to deploy my container to my default workspace in my Kubernetes cluster. So once that's deployed, I'll run that rad app connections again, and we should see the underlying Kubernetes resources that were created just to run that particular container. Now, Radius environments map how applications kind of run or bind, to a particular platform. So earlier when we saw our application compute was set to Kubernetes, and the namespace was, let's see what the namespace name was. It was the default namespace. That means that container resources are deployed to that default namespace in the Kubernetes cluster where it's installed. So we're running this in Azure Kubernetes.
Sorry, quick question, Will. Why is this under containers, even though it's under Kubernetes previously? Because
so this is
demo...
you talking about the namespace?
Yeah, this is application. This namespace is containers, but where it's configured is Kubernetes.
Yeah, so that's probably a design choice that the Radius product has made. So containers are kind of like the core components of your application. So whether that was an intentional design choice or not, I'm not sure, but that's a kind of naming convention that Radius uses.
Okay.
Cool. So now that's been deployed, I'm actually going to run that application. Again, that's going to build my application, then it's going to deploy it. It's going to build the bicep file, then it will deploy it. And then hopefully what we'll start to see is a bit of a log stream. Now here I've specified the port to run on 3000. So if I look at it, it's essentially now forwarded that to my local host on port 3000. So there it is. There's my Radius application all up and running. There's nothing connected to it yet, but I can see some metadata about this particular container. You can see some process information, any environment variables, purely because that's what this container image shows. This is like a default container image that the Radius project provides. If this was your application, you wouldn't want to be providing environment variables unless you were feeling lucky or bold. I don't know. But here we've kind of got a to-do list as well. And we see this little warning text here. So no database has been configured. So items are going to be stored in memory. So if I'm adding a test item now, that's all done in memory. Now, storing things in memory isn't great. We'd like to have a database. So what I'm going to do is I'm going to go back into Visual Studio Code Insiders, and I'm just going to stop that that log stream. So now what I want to do is I want to add a database and connection. So what I need to do is I need to just add a little bit of a parameter for my environment. And then what that's going to do is that's going to pass it to my new MongoDB database. So here, because of that extension, we can get all of these specific kind of Radius resources already for us. So I'm going to create a MongoDB database. I'm just going to name this real simple, MongoDB. And then I'm going to say, okay, it belongs to the environment that I've defined in Radius, and it's also going to belong to this application. So when we added this Mongo database, we didn't specify how or where we needed to run the underlying infrastructure. So essentially what the Radius environments and recipes do is they actually take care of that for you. So just like how your Radius environment is bound to your container in a Kubernetes cluster, it also deploys and binds your MongoDB database to underlying infrastructure using recipes. And we can actually learn about this, the recipe, a little bit more if we want to get more information. So say if you're developing recipe or you're working with recipes as a developer, you know the resource type it is, but you don't know anything about the recipes and what you can provide it. You can just run this rad recipes show command. And what that will do, it will give you some details about the recipe itself, including kind of available parameters and defaults. So this is the kind of the defaults for MongoDB. For Redis cache, it might be what particular SKU you can deploy that, where you want to deploy that cache, etc. Cool. So now that I've defined my MongoDB database, what I want to do is add a connection. So all I need to do is just add this connections property here and say MongoDB, and then just use the resource ID for that MongoDB resource I defined earlier. So if you've developed in Bicep before, if you worked a little bit with Bicep, this should feel very, very familiar to you. Cool. So now that that's kind of all hooked up, let's run that again. So that's going to build my application again, or build my template again. And then it's going to deploy not just the application I defined earlier, but it's also going to deploy my MongoDB database as well. So when I go back into my container, what we should hopefully see is that MongoDB will show up as the MongoDB resource that I've just created will show up as a Radius connection. And when we add items for our to-do list, if we're not doing it in memory, we're actually storing that in Cosmos DB. So log streams coming through. Very busy. Let's go to localhost, see what's happening. There we go. Just took a little bit of time. So there we go. There's my MongoDB database. So there are all my environment variables. So that's all been connected up successfully. If I go into the to-do list now, I can see that warning text has disappeared. So as I'm adding items to my to-do list, that's now being persisted in MongoDB rather than in memory. And then if we go back into Visual Studio Code, I'm just going to stop that log stream. If I run my rad app connections command again, we should see that now I've got these MongoDB resources along with the underlying Kubernetes resources that were created to run that MongoDB container. Now, in addition to kind of adding more dependencies, what we can do if we're working particularly with microservices architecture, we can actually add more containers to our application to make it more modular. So to do that is fairly straightforward. So say, for example, I've got a backend resource that I want to add. I can add another container to support that. So this is just going to be a simple nginx backend. So application. Say I'm defining my Radius application. I'm just going to use latest nginx image. I'm going to expose that on port 80. And then to actually connect that to my front-end container, it's very similar to how we've defined this MongoDB connection. So I just type in backend, source. I'm actually going to point it to the port that I've exposed that container on. So the name of it, followed by the port that I'm going to expose it on. So deploy this, go back. I'm just going to go rad run that bicep file again. And then hopefully what we should see is this is another Radius connection. So we should see that backend connection appended to our application. So we should be able to see both our information for our MongoDB database and also our backend container as well. So when you kind of do technical demos on YouTube, you can do like with the power of video editing, but that's okay. So if I go back into localhost 3000, what's going on? There we go. Okay, so I've got my connection for MongoDB, and then I've also got my backend defined as connections as well. So there, I've exposed it on port 80, the name of my host name of my backend container. So that's added as a connection in my Radius application.
So, Will.
Yes.
You just added that backend, and then you redeployed it. You redeployed your app.bicep, and I noticed that it now started to deploy the backend first before it deployed the demo app. Does it sort out dependencies by itself? Because you said, hey, this is my backend. You need this connection string, so I will make sure the backend is running first. Does it do it automatically?
Yeah, so in kind of like the Radius application, it has a kind of like a graph, so it understands all your various different dependencies. So it's very much like, okay, this container needs to be up because my front end container is connecting to that back end. So like you said, it will deploy the back end, then the MongoDB database, and then it will deploy the container. So it'll make sure that those two dependencies are up before the front end application is deployed.
That's cool. All right.
Cool. And then finally, what we want to do is let's add a gateway to this to our application. So
well, you didn't define the dependency though. It just automatically deployed by using dependency graph with what you define it in code, in bicep code.
Sorry?
You didn't define any dependencies for it to deploy first, because you
not
just
to deploy first.
Yeah.
The dependencies are defined within this kind of bicep file. So I'm saying that within this kind of front end container, it's going to connect to a back end container and also MongoDB database.
Okay.
So Radius will kind of build up the application graph to then say, okay, deploy your back end container first, then your MongoDB database.
Okay, so then it's smart enough to know it by the code that to deploy it first. Okay.
Cool. So now finally what I want to do is, rather than hit localhost port 3000 every time, I'm going to add a gateway to my application. So here, just define a gateway resource. So there, it's under the core kind of namespace. So create my gateway. It's going to live inside my Radius application. Then I'm going to define the route. Need to provide the path. Then the destination. I'm going to say, okay, that destination is going to be on port 3000. I'll just use demo as a prefix. So once I deploy that, now it's not just going to deploy my backend container, my MongoDB database, my gate. It's now going to deploy my gateway as well. So what we should see is a public endpoint that we can use to kind of hit and use the gateway URL in our browser. So instead of connecting directly to the container, Yes, I do want to open that. Should be fine. We see our application now. So rather than hitting localhost or hitting our container directly, we can actually hit hit our gateway immediately. Oh. And there's our items that we added earlier. Awesome. So really quick, simple introduction to Radius. You do have a lot of options here. So I won't do this now because I've been playing around with this and it does take a little bit of time to kind of fix up. But say if I wanted to add a cache for a reason, just add a Redis cache. Essentially, all I need to do is just define it here. Application. Now, by default, this will use kind of the default provider in Radius, or that comes out of the box to deploy a Redis cache. So that's just going to deploy a specific container. But what we can actually do is we can actually name a specific recipe as well that we want to use. And if I just type in Azure, when I then deploy my application or my Radius application, that's going to hit the Radius API and it's going to look at, and the universal control plane is going to say, okay, this Redis cache needs to be deployed in Azure. I'm going to route to the resource provider for Azure to go ahead and create that cache for me. In terms of permissions, essentially, at the moment, it uses kind of service principal. So you create a service principal, that you then register that within your Radius environment. And then once you've registered that credential within your Radius environment, you can go ahead and essentially provision resources within your cloud provider as well. So if I deploy that now, I'm going to get a 403 error or 401 error because I haven't granted this particular Radius environment the permissions to go and create resources in Azure. But Radius has this concept of, okay, this is a service principal. I can actually delegate permissions to Radius to go ahead and create resources in Azure myself on our behalf. You can also add Radius to existing applications as well. So if you've got Kubernetes manifests, essentially you can add annotations to say, okay, we're going to enable Radius for this application, and then just use the kube control commands to deploy your application like you would with any normal application with Kubernetes to deploy your Radius applications as well. Cool. So if I just go back to slides, I will swap presenter mode. Cool. So if you want to learn more about Radius, really recommend the docs. It's a good place to get started. It is a really recent project or recently released project, so it's still very much a work in progress. The GitHub repo itself, there's a lot of activity going on there. If you even want to contribute to Radius itself, it's a great place to start and just have a look at what's going on with the project. There's also a full hands-on lab that the Radius project folks have provided as well. So this takes you, this is a whole 60-minute lab. It takes you right from the beginning, from creating your own application to kind of using recipes and deploying it to various different clouds. And that's pretty much it for this presentation. Thanks for having me. Thanks for accommodating me, Nick and Wesley. I appreciate the time difference is always a bit of a challenge for Australia and UK. But if folks want to connect with me, Velida is a pretty unique name, luckily or unfortunately, depending on the context. Yeah, I'm on Twitter. I won't call it X. LinkedIn. I do some stuff on GitHub. I also have my own blog post as well. I sometimes do stuff. I should do more YouTube stuff. But anywhere on the internet was Velida. Come and hang out, ask questions. Love to connect.
Very nice. Very nice. One thing that popped out to me, and it also kind of links into the previous session, when you were defining your resources, I also saw that we can pick Dapr and specifically pops up. So I could do the whole thing and go, all right, I've got Dapr got my application. I've got Dapr as a sidecar, and then I've got a Redis cache in Azure. You showed us. I could just do all that and make my developers happy.
Yeah. So what Radius has, it has kind of resources that kind of integrate with Dapr. So I believe state stores, if you're using Redis cache as a state store, you essentially define it as it lives under the namespace applications.dapr, then state stores. So yeah, then it's just those recipes that kind of interact with Dapr components that you can use within Radius as well, which is really cool.
I like it. Pretty excited. And I think this is probably the best and well-structured demo on Radius I've seen so far.
Oh, thank you.
Building it from scratch. That's, I know Redis cache and Azure, it takes about 20 minutes to provision, I think. I tried it in the demo the other day. I'm like, I'm not doing that again ever.
No.
But this was structured so well that there's a recommended viewing for people.
Oh, thank you. There was a show in the UK called Blue Peter, and they say, here's one I've made earlier. That is the go-to joke that I've always made in every single demo that I know is going to take like 20 minutes to provision.
Yeah, it's good. Good session. Thanks.
Thank you.
Well done. Yeah.
One question: have you tested Radius for any client set before, just like a POC? You do?
No, this has all been POC work and trying to show people what Radius can do.
Yeah.
I'm working with one client at the moment where dev and ops kind of do work together quite a bit. So I'm just like, okay, this could be really powerful for you guys. So we'll see. I'm hopeful that pretty soon in the future people start to adopt Radius a little bit more.
Any thoughts on the name Radius?
It's interesting. I'm terrible at naming things, so I don't really judge. Everyone has an opinion on the naming of Dapr as well, which I kind of disagree with, because if you're coming from a Norm background, there's that all that joke. I just like the fact that inside Microsoft it was Project Radius, and then when they released it, they just flipped it over. They were just like, yeah, it's good enough. That's the attitude I have.
I've got an ops background, so for me, Radius, when they released Radius, I thought about Radius authentication in Active Directory. And that was like a long time ago, but that's the first thing I thought of. I'm like, what just happened? But no, it's fine. I love the product.
Make new things. We don't have to come up with new names. It's fine.
No, that's fine. I hope. As a developer platform, it's very promising, and I hope it's got a great future.
Yeah, me too.
Okay, so let me just play a little intro video, and then we can have a little chat after.